All right, let's talk about one of the biggest challenges in AI right now. How do you take these super smart general purpose models and turn them into a reliable expert? Someone you'd actually trust in a high stakes field like law or medicine. That's what we're diving into today.
So think about this for a second. An AI can pass the bar exam, but you'd be crazy to let it be your lawyer, right? And that question, it really gets to the heart of the issue. I mean, we've all seen the headlines about LLMs just crushing these incredibly hard professional exams. But if you actually try to use one as your lawyer, yeah, you can end up in some serious trouble. There's this huge gap between passing a test and actually doing a high-stakes job, and that's the gap we're trying to close. And this really breaks down that paradox. On one side, you've got your standard generalist LLM. It's super fluent, it knows a little bit about everything, and yeah, its abilities are honestly pretty impressive. But, and this is a big but, for any kind of professional work, it can be dangerously unreliable. It just makes stuff up. It's a problem the experts call hallucination. What we're aiming for is the specialist AI over on the other side. Something that's precise, deep, and, this is key, has knowledge you can actually verify. That's what makes it trustworthy and accountable.
Okay, so why are they so unreliable? Well, these generalist models are trained on, the entire internet. That means they don't have the super specific vocabulary or the subtle, nuanced way of thinking that a real expert has. Plus, their knowledge is basically frozen in time at the moment they were trained. Now, the old way to fix this was to retrain the whole model from scratch. But with these giant AIs, that is just way too expensive and way too slow. We've got to find a smarter way to turn them into specialists. So how do we actually do it? The best way to think about it is like this. A generalist LLM is like a brilliant new college grad. They're super smart, they know a ton of stuff, but you're not going to let them perform surgery on you, right? They need specialized professional training. And that's what we're going to look at now, the two main tools in the specialist's toolkit. First up is a technique called Retrieval-Augmented Generation, or RAG for short. Seriously, the best way to picture RAG is that it gives the AI a library card. But not to just any library, to a specialized private library full of expert knowledge. So instead of trying to just remember everything from its training data, the AI can now look up the latest, most accurate info from a source we trust. And it does this in real time, right as it's answering your question. This is what grounds the AI in actual verifiable facts.
And the process itself? It's a really simple but super powerful two-step dance. First, the retrieve part. The system goes into its knowledge base, say a database of legal statutes or medical journals, and pulls out documents that are relevant to your question. Then comes the generate part. It hands those documents to the AI with one simple, crucial instruction. Answer the question, but only use the information I just gave you. That simple rule is an incredibly powerful weapon against the AI making things up.
All right, tool number 2 is called Parameter Efficient Fine-Tuning, or PEFT. Now stick with me here. If RAG is the AI's library, PEFT is its intensive residency program. This is how we teach the model the skills, the behaviors, the instincts of an expert. And here's the genius part. Instead of retraining the entire massive model, PEFT methods just tweak a tiny fraction of its internal knobs, its parameters. We're often talking less than 1%. So you get all the benefits of full training, but at a tiny fraction of the cost and time.
And the most popular way to do PEFT right now is a method called LoRA. It stands for low-rank adaptation, but the concept is what matters, and it's brilliant. You take the original massive AI brain and you freeze it completely. Don't touch it. Then you bolt on this tiny extra layer of trainable parameters. It's like adding a small tweak module that guides the model's behavior. The key thing to get is you're not rewriting its core knowledge. You're changing how it thinks about that knowledge.
But here's the real magic of LoRA, especially for anyone putting this stuff into a real product. Once you're done training, that tiny tweak module can be merged right back into the main model. So what does that mean in practice? It means you get a smarter, more specialized model that is exactly as fast as the original one. There's zero extra lag, zero latency when you ask it a question. For production systems, that is a huge win. Okay, so we've got these two amazing tools, RAG for getting the facts right, and PEFT for teaching the skills. So which one do you choose? Well, the real breakthrough, the key insight here is that you don't have to choose. The best approach is to combine them, to build a hybrid expert that gets the best of both worlds. And this is really the optimal strategy. You use something like LoRA, that's our PEFT method, to teach the model how to reason like an expert. You instill the style, the vocabulary, the patterns of thought. Then you give that newly skilled model RAG,
giving it a direct line to verifiable, constantly updated facts. It's perfect synergy. One teaches the skill, the other provides the knowledge. So let's just recap that because it's so important. Think of it this way. RAG is the specialist library. It's all about accessing dynamic, verifiable knowledge. PEFT, or LoRA, that's the specialist training, the residency program, that ingrains the skills and behaviors. To build a true AI expert, you really, really need both. Okay, that's the theory. But what does this actually look like out in the real world? Let's take a look at how this hybrid approach is being put to work in some incredibly critical fields. Let's start with law. In the legal world, making up a court case isn't just a small mistake, it's a catastrophic failure that can get a lawyer sanctioned. So you can see why RAG isn't just a nice to have, it's an absolute baseline requirement. Every single claim has to be traceable back to a real document. And, at the same time, they're using PEFT to teach the AI how to think like a lawyer, training it on specific reasoning frameworks that guide it through the logical steps of a legal judgment.
Okay, now for medicine, where the stakes are literally life and death. The biggest fear here is that an AI trained on old medical data could actually make existing biases worse, which is a massive threat to patient safety. That's why having a human in the loop is completely non-negotiable. So right now, the most effective and safest role for these LLMs isn't to diagnose a patient from scratch. Instead, it acts as a synthesis engine for doctors, taking clean, structured data and summarizing it to help the human clinician make a better, more informed decision.
And then there's science, which is maybe the most ambitious application of all. The goal here isn't just to find information that already exists, but to help scientists generate brand new, testable hypotheses. It's about accelerating discovery itself. And the really cutting-edge approach here is to combine LLMs with something called a knowledge graph. I love this analogy. They use the LLM as a creative intuition engine to spark new ideas, and then they use the structured, logical knowledge graph as a logic engine to check if those ideas actually make sense.
So you can see this hybrid approach is already proving to be incredibly powerful. But we're not at the finish line yet. So what's next? What are the big hurdles we still need to clear on the path to building these expert AIs? Well, there are a few big challenges that everyone's working on. First, there's model drift. The world changes, and an AI trained today can quickly become outdated. Second, there's just the raw complexity of managing all of this. Imagine trying to keep track of thousands of these specialized little AI models. It's a huge operational headache. And finally, and this is without a doubt the most important one, building in the ethical guardrails to make sure these systems are fair, private, and accountable to us. When you look at all this, it becomes pretty clear that the future isn't one single, giant, all-knowing AI. Instead, what we're heading towards is an entire ecosystem of specialized AIs. And the goal is for these systems to be automated so they can adapt on their own, completely verifiable so we can trust their outputs, and able to learn continuously so they never get stale. So this all brings us right back to where we started. After looking at all these tools and all these challenges, what is it that really makes an AI an expert? You know, when you boil it all down, it's actually pretty simple. True expertise, whether we're talking about a person or an AI, isn't just about knowing a lot of stuff. It's about knowing the limits of your knowledge. It's knowing what you don't know and having the process and the discipline to go and verify it. That's the real foundation of trust. And that right there is the future of expert AI.